Hi everyone, welcome to my YouTube channel, and for today I will be giving you a discussion about evaluating functions, a video tutorial for grade 11 general mathematics class. I am Philip Jason Falses, a senior high school teacher at Mayor Ramon A. Benjamin Senior National High School, Dacoton, Dumarao, Capiz. To begin with, allow me to present to you the session objectives that we have for this video recorded class. First, to recall the concepts of relations and functions, and secondly, to represent real-life situations using functions, including piecewise functions. Now, as a review, allow me to name or to define some terms related to the study about functions, and what you need to do is to rearrange the letters and to identify what is being defined. So first we have, it is a relationship between two variables x and y. So if you know this, you can answer, this is relation. Secondly, it consists of x and y coordinates. This is two words. We have ordered pair. Next, it includes the set of x values. What do we call this? If you know this, you can jot down your comments in the comment section. This is the domain. And we have the set of y values. This is what we call, in 3, 2, 1, this is our range. So you got all these definitions right about functions and relations. So what do we need to do is to proceed. Allow me to give you a poem about my math problem by solongi.ng. This has something to do with our discussion about functions and relations today. So the poem goes this way. I thought the relation of you to me is said to be a function, but reality spoke something else. That you correspond to two guys, me and the other one. Thus, a relation is not a function. This poem has something to do with most of you, especially teenagers, experiencing love triangles and the likes. So how do you feel if your special someone already has a special someone, or he or she has someone else? So this, according to this poem, this relation is not a function. So that makes sense because our question in the first part of the lesson talks about, is relation a function? Is relation a function? How can a relation becomes a function? And goes that way. So what have you remembered about relations and functions? So maybe you were able to know these things in your junior high school, but then let me define once again the difference between the relation and the function. So it says here that a relation is any set of ordered pairs, and the set of all the first elements of the ordered pairs is called the domain of the relation, and the set of all second elements is called the range, which were discussed in the previous slides. Now, function here is a relation. That means our function exists within the relation, or rule of correspondence between two elements, the domain and the range, such that each element in the domain corresponds to exactly one element in the range. So let us try to identify or to discuss this further in the following slides. So given the following ordered pairs, which relation is a function? So we have the following ordered pairs, or a set of integers. We have for A, 1 and 2, 2 and 3, 3 and 4, 4 and 5. For B, 3 and 3, 4 and 4, 5 and 5, and 6 and 6. Those are pairs of x and y's. For C, 1 and 0, 0 and 1, negative 1 and 0, and 0 and negative 1. And for D, we have A, B, B, C, C, D, and A, D. So the question is, given the following ordered pairs, which relation is considered or can be considered as a function? So the answer is The relations A and B are functions because each element in the domain corresponds to a unique element in our range. So what about C and D? So it says here that the relations C and D are not functions because they contain ordered pairs with the same domain. So for C, they have the same value of x, which is 0. So for 1 and -1. So that makes it not a function, or this is just a relation. And for D, we have the same values of A for AB and AD, the same value of our domain. So that makes it not a function. So if you are still confused, let us try to discuss further. A function is a relation in which every input is paired with exactly one output. So input is A, output is our B. So you need to focus on the x coordinates when given a relation. So that means the values in A are the values for the x coordinates and the values for B are the values for the y coordinates. It says here that if the set of ordered pairs have different x coordinates, if the values of x are different, it is a function. In the local term, dapat wala ga parehas ang sa values ng A based on this illustration or the value of your x coordinates. If the set of ordered pairs have the same x coordinates, it is not a function. So if they have the same x coordinates, they have the same values in A, it is not a function. So tulok lang gid, always have to focus on the A values or the x values based on this definition. Now, y coordinates have no bearing in determining the functions. So regardless of if it has different or if it has the same y coordinates values, it has no bearing in determining the functions. So your function notation can be expressed in this way. Take note that y is the same as f of x, or f of x is equal, identical to y. Y means a function and f of x also means our function. So y here, based on this notation, is the output. That means to say, what is the possible value or output when you get the value of x? F is of course the name of the function and x is the input. So y output, f name of function, and x is our input. So for example, determine whether each relation is a function. So we have these examples. So you need to determine if this relation is a function. So we have 2, 3, set of ordered pairs, 3, 0, 5, 2, and 4, 3. So we must look at the values of the x. Do we have the same values of x based on this definition or based on this example? So the answer is there is no same value. So yes, every domain is different. So every domain is different. That makes it a function. So this relation is a function. Secondly, we have 4, 1, 5 and 2, 5 and 3, 6 and 6, and 1, 9. So if we have to look at it, you have to ask yourself, do we have the same values of x? So based on this definition, we have the same values of x, which is 5. So it is paired with two numbers, the 2 and 3. So it is not a function. Now, we also have the vertical line test. What is the vertical line test? This is a relation between two sets of numbers can be illustrated by graph in the Cartesian plane, and that function passes the vertical line test. So what does it mean? If any vertical line passes through more than one point of the graph, then that relation is not a function. Take note of it. If it passes through more than one point in the graph, it is not a function. So are these functions? So if we have to look at it, if it passes through more than one point, it is not a function. So it passes only one point. So it is a function. Another one, it is a function. And another one, it passes through, okay, it is not a function because it passes more than one point in our graph. So we have here and on this and many others. Okay. Next, another one. Is it a function? You can go with me. It is a function. This one, oh, it is not a function. So if we have to look at it, it passes to more than 1 point. So it is not a function. What about this one? Function or not, it is, okay, no way, because it passes more than 1 point in the graph. What about this one? It is, okay, it is a function. So I hope you were able to find out how vertical line test works based on the definition that we have. Now we are down to the second part of our lesson, which is the recalling the process of submission and evaluating our functions. So it is important that we know how to evaluate functions, and we need to understand the basic process of substitution to be able to evaluate a function. So before we go through, let us try to review or identify some of the common types of functions discussed in your modules or in your books. Actually, it only contains a few of the most common types of functions. So we have the first one, a function that has the same input value no matter what input value is. We call that as the constant function. If y is equal to 7, it will always be equal to 7. Next, the identity function, it is a function which returns the same value which was used by its argument. This is actually identity function. Example, f of 2 is equal to 2. So there is something wrong with typo error. So that should be identity function. The definition is a function which returns the same value which was used as its arguments. Next, the polynomial function. Actually, polynomial alone is already a function, but it has many babies, the polynomial. The first one is the polynomial function with 1 degree. Of course, that is a linear function. Just like algebraic expression, we have also linear function. Of the second degree, this is the quadratic. So y is equal to 3x squared. That symbol there is raised to the second power because we cannot perform the second power in the PowerPoint. Next, any function which can be represented, or any function, polynomial function of the third degree is called the cubic. So linear, quadratic, cubic. Degree 1, degree 2, and degree 3. Next, any function which can be represented by a rational fraction, we call that as a rational function, and we will be having more of that in these lessons. Next, functions in the form y is equal to ab raised to x, where x is an exponent and a and b are constant. So we call that as the exponential function. And the inverses of exponential function, and any exponential function that can be expressed in logarithmic form, we call that as our logarithmic function. So those are just some of the basic types of functions that we know or that we have. Now, what is evaluating function? It is important that we know what is evaluating function, because when I ask you to do the process and when your subject teacher asks you to evaluate a function, you should know the steps and you should know how to do the process. So it is the process of determining the value of the function at the number assigned to a given variable. Again, the process of determining the value of the function at the number assigned to a given variable. So there are numbers assigned to a given variable that we need to perform. We need to get its value. So just like in evaluating algebraic expressions, to evaluate function, you just need to, what you need to do first, replace each letter in the expression with the assigned value. If there are letters in the expression, you just have to replace each letter by the corresponding value assigned to it. Secondly, perform the operations in the expression using the correct order of operations. See, it is a must that you have to be familiarized, or you have to remember the process of the operations of functions. So which should come first? Multiplication, subtraction, division, and the likes. So look at these examples that we have. This is found on the modules that I have distributed to my students. Example, Given that f of x equals 2x minus 4, find the value of the function if x is equal to 3. So what you need to do, based on our instruction or direction, replace each letter in the expression with the assigned value. So the latter is x, so we need to replace the value, find the value of x when x is equal to 3. So what is the value of the function? So that will be f, substitute x by 3. F of 3 is equal to 2 times 3, which is the value given, minus 4. So substitute 3 for x in the function. Then f of 3 is equal to 2 times 3 is 6 minus 4. So that is simplifying the expression on the right side of the equation. So that is 6 minus 4. F of 3 there is equal to 2. So that's how easy it is. If x is equal to 3, then f of x equals to 2x minus 4 is equal to 2. Second example, we have, given that g of x is equal to 3x raised to the second power plus 7. So find g of negative 3. So what we need to do, we have to replace the value of negative 3 to the value of x. So we have g of negative 3 is equal to 3 times negative 3 raised to the second power plus 7. So again, following the rules in algebraic expression, we have to carry first, to solve first, to remove first the parentheses. So we have to negative 3 raised to the second power, that is negative 3 times negative 3, that is 9. So 3 times 9 plus 7. To simplify the expression, 3 times 9 is 27 plus 7, so that becomes 24. That means to say g of negative 3 is equal to 24, or 34 rather. Next, given that f of x is equal to 3x minus 2, find so f of 3. So this is just a simple way of simplifying an expression. So that is 3 times 3, which is the value of f of x, or x rather, minus 2. So 3 times 3 is 9, minus 2, that is equal to 7. Another one, we have 2 of negative 2. You have to find the value of x if the value of x is negative 2. That is negative 2. Simplify, substitute. We have 3 times negative 2 minus 2. That is 3 times negative 2 is negative 6 minus 2. That becomes negative 8. So don't be confused with the signs. It is a must that you need to be able to be familiarized with the basic signs, especially in sign numbers, in algebraic expressions. We're down to our fourth example. Given that h of z is equal to z raised to the second power minus 4z plus 9, so find h of negative 3. So the value is negative 3. We have, so negative 3 raised to the second power minus 4 times the value of z, which is negative 3 plus 9. So that becomes negative 3 raised to the second power is 9. Negative 4 times negative 3 is positive 12 plus 9. So it becomes, the answer is, of course, 30. So h of negative 3 is equal to 30. And the last example, this looks complicated, but let us try to solve this one. Given that g of x is equal to the square root of 3x minus 2, find g of 9. So for our solution, substitute 9 for x in the function. So we have g of 9 is equal to the square root of 3, the value of x there, g of x is 9. So 3 times 9 minus 2. So that is 3 times 9 is 27. If we simplify the expression, minus 2. So 27 minus 2 is equal to 25. So to get the square root sign, you get to have the square root of 25. And that is equal to g of 9 is equal to 5. So those are some of the examples on how we can evaluate our function. Now, reminder, let me remind you that just like in algebraic expression, to evaluate function, we have to first replace each letter in the expression with the assigned value, and secondly, perform the operations in the expression using the correct order of operations. As I end, always remember that whatever problem that is, just like a problem in functions, when evaluating functions, it can be solved in many ways. Just like in life, any problem in life can be solved in many ways. So let us try to look at it, that when we are facing the giants, we are facing a lot of problems in life, it can be solved in many possible ways as long as we are grounded by the direction and the rules in solving our problem. So that would be all for my video tutorial for grade 11 mathematics. Should you have questions or clarifications, you just have to drop by in the comment section. And if in case you miss, please like and subscribe to my YouTube channel for more videos about tutorial related to mathematics. That would be all. Thank you.